like we said, we'll be looking at isotopes today. So, pretty much, what's an isotope? So, an isotope, or rather isotopes. So, isotopes, these are atoms that have the same atomic number but different mass numbers. So, remember, what did we say about atomic number? Atomic number is the number of protons in an atom, whereas the mass number, this is the sum of the protons, or the number of protons, and the number of neutrons. So when we say isotopes have got the same atomic number but different mass numbers, then what we're basically saying is the same as they've got the same number of protons but different number of neutrons, right? And there are quite a number of isotopes which are very, very important. And so we'll look at some applications for radiocarbon and also for radiocarbon 14. But for now, we'll look at the three most common ones, right? So which are chlorine, hydrogen, and carbon. So here we've got hydrogen. So let's start from hydrogen. So hydrogen, there are three isotopes of hydrogen. So what does that entail? So there's hydrogen 1, hydrogen 2, hydrogen 3. Hydrogen 1 is also called ordinary hydrogen. Hydrogen 2 is also called deuterium, and hydrogen 3 is also called tritium. Now, why is this important? So this is really, really important because the numbers that I'm adding at the end, that signifies the mass number. So when we talk about hydrogen 1, what we are basically saying, we know that the atomic number, the number of protons, is going to be the same. There's always going to be one proton, right? But then where is the difference? The difference comes with the number of neutrons. So if we say hydrogen 1 or ordinary hydrogen, what we're basically saying is that if we were to calculate the number of neutrons, which we can find by saying number of neutrons is equals to mass number minus atomic number, then you're going to find that hydrogen 1 has no neutrons. Hydrogen 2 has 1 neutron, and hydrogen 3 has 2 neutrons. Okay, then when we go to carbon, when we talk about carbon, what are we going to have? Carbon has got carbon 12, carbon 13, carbon 14. Again, the same principle, right? So when we talk about carbon 12, it's got how many? Remember, number of protons remains the same in isotopes. So, because remember, if the number of protons changes, then you're not talking about another element. Okay, so carbon. So carbon 12, this means that again, how do we find number of neutrons? Number of neutrons is equals to mass number minus atomic number. So you're going to say 12 minus 6. So you're going to have 6 neutrons. Then for carbon 13, you're going to have 7 neutrons. For carbon 14, you're going to have 8 neutrons, right? Okay, so now, and then we now have chlorine 35 and chlorine 37. Now, this is really interesting because I want you to work out the number of neutrons in carbon, or rather in chlorine 35 and chlorine 37, and drop it in the comment section. I'll definitely be looking out to see your answers. Now, when we talk about radioactivity, this is very, very important because there are certain isotopes which are radioactive, right? So radioactive, this means that they are able to emit certain radiation. And so over the years, these have been very, very important in use, such as archaeology and also medical. And because this is medical biology, so we're definitely going to talk about the medical one, but as well as the archaeological one, because that can have that's equally important. So I'll begin with medical. So medical, we've got what we call radiocarbon. Radiocarbon 60, that's very, very important because it's used in radiotherapy. Okay, so you will notice that my notes here were saying chemotherapy, but it's actually supposed to be radiotherapy. But here in these ones, it's been corrected. Okay, so radiocarbon 60, this is very, very important because this is used in radio, so it releases rays or certain radiation, which is actually very, very important when it comes to the treatment of cancer. Okay, and then when we talk about radiocarbon 14, you will remember from history where we talk about, when these ancient artifacts are found and all these things, dinosaur parts and everything, to be able to date them, the radiocarbon 14 is very, very important. So that's about isotopes and radio activity. And for these isotopes which are also radioactive, we call them radioisotopes. So the next video will be talking about bonding, covalent, ionic, and then we'll also be talking about the hydrogen bonds. So join me for that.